All of the products start with a design concept from Dave, myself, and Gabe, and a couple of the other guys. And we will generate a drawing in SolidWorks. And this is a rendition of an R121 transducer. So now that this product has been in production for about 20 years, we have them dialed in perfectly. And then we send the raw materials out for processing with a aerospace company, and they come back in raw form this way. Okay, so all of the products are done in small batches, usually less than 50, and it gives us the opportunity to keep a very tight control on everything. And the first thing that we do when we get a batch in is we will check all the dimensions against the master blueprints. And he will be checking each individual part to make sure that they're within our tolerance, which we keep within 1 to 2 thousandths of an inch. And unlike some other manufacturers, parts like a transducer, these are carved from actual billet, low carbon steel. We do not stamp anything. Everything is from a block of metal, which is a more expensive way to do things. Also, all the parts are individually serial numbered so that this end cap will go with that particular serial number microphone. And this just gives us a very close consistency from item to item. So after the products are sent to the plating company, they get bead blasted and an electrolysis nickel finish on top of a copper plate. And they will come back to us. We will inspect everybody to make sure that there have been no nicks, scratches, or imperfections. Then they will come to this station, and a couple of things happen. The first is that we will take a baker's enamel, it's like a crayon stick, and we will fill all of the serial numbers and the model numbers. And then you end up with a nicely inked engraving. After we've inked the serial numbers and the copy on the front of the microphone, we'll prepare to put the logos on. After he glues the logo on, he's going to put it in a clamp, and it's going to sit in a clamp for several hours, and then he's going to peel any of the residual glue that has leaked out from the clamping process, and then those will sit overnight. For the buildup of the transducer, we're using neodymium supermagnets, and they come in different grades or strengths, and we use the maximum grade that's available. It's called grade 52. So what we have to do is have them put in such a way that the adhesive, which is a two-part adhesive, will instantly bond the magnets upon contact. So he's going to set up the accelerant, which is going to cause the chemical reaction, and then he'll put the adhesive on the other component and put them in a jig, and you'll see a quick little snap with the jig, and the parts are now permanently attached. Okay, well, the next step in the process is corrugating the ribbon. And something very unusual about the ribboning process that we do here, we use what's called the direct corrugating method. And most vintage microphones and other manufacturers use the RCA type method, where the ribbon is actually sandwiched between two pieces of glassine paper and then run through some very tight gears. So we found out that by doing a very precise corrugation using calibrated gears, that we could make a corrugation that was more resilient than the standard corrugation. In fact, it's so resilient that we have, after it's done, we have to stretch the ribbons out a little bit to relax the corrugations. And that happens in two phases. Once when he puts the ribbon in and tunes it, and then after the ribbon has been clamped down, he will blow on the ribbon and further relax it. Okay. And then it will be finished. Now to tell how tight or loose a ribbon is, you can't really feel it. So we have an electronic method that we use to tell how tight or loose a ribbon is. And he's going to attach a couple of alligator clips to it, which will give him an idea of what the tension is like currently, untuned. So he's going to his oscillator. We use an XY function on an oscilloscope, and we'll see that an untuned ribbon, or at the point of non-resonance, will create an oval. And at the point that the oval closes into a straight line, that is the impedance rise. And he will get a numerical figure on his frequency counter, which will tell him if the ribbon is too tight or too loose. So this is a process. It's blowing, realigning, blowing again, and when he finally gets to a point where the resonance is where he needs it to be, then he'll tighten the clamps down, and that will lock it into place permanently. All the circuit boards for the various models of microphones are wired in-house, and nothing is farmed out. And here again, we're always using a Teflon jacketed wire for longevity. And when you're working with parts this small, consistency is very important. All of the transformers that are used in our products, we design them from top to bottom. And after the transformers are made, each transformer is tested, and we grade the inductance and the permeability of the transformer so we know that it'll perform properly when it's put into a microphone. This is the final assembly process where we marry the transducer and transformer to the microphone barrel. And one of the things that we put in there to keep the microphone from developing any rattles or loose components later is a little bit of cotton. And then the final step is to put the end cap on. And then the mic's inserted into a plastic bag so that as it travels around, nothing will scratch the finish.
And now we're measuring the sensitivity of the microphone. Minus 36.7 dB. Yeah, it's well within specification. Now this switch switches between testing microphones and testing circuit boards. Now there are standard operational tests we do on the circuit boards. Frequency response, distortion, and gain. And this unit will give an unequivocal indication of what's happening. And we plug the circuit board into, since these are phantom powered, this box basically provides for phantom power, and it keeps the DC phantom power off the input of the test set. Okay, we're getting a steady state noise of say 118 dB, which is right where it needs to be. Gain is actually an insertion loss of a half a decibel, which is where that needs to be. Frequency response, you'll see it begins to fall at 100 hertz. Still very much within spec. Now we're measuring the distortion. And the distortion now is a very small fraction of a percent. And right here, this would correspond to a ridiculously loud sound, and the distortion is still well under 0.5%. So with these tests, I know the condition of this circuit board, and if it were to fail any of these tests, that would be cause for immediate rejection of the board.
The final process in the manufacturing phase is he will get a series of microphones that need to be QC'd and packed up, ready for sale. And the first thing is that all of the data from the testing procedures are entered into a computer, into a master database, and he will take this data, and any matched pairs that are here, he will put those aside because those are sequentially numbered, and those are tracked differently from standard single microphones. So the first thing he's going to do is he's going to give the microphone a visual inspection and make sure that there are no marks, that no screws are in the wrong places, that there are no blems or imperfections in the finish. And then after he's done with that, he will assemble all of the things that are going to go in the packaging. After he inspects the microphone, he's going to put it in the case, and he'll start to put the accessories that are going to accommodate that mic, the mic clip, the mic sock, and seal up the box. So he's going to put in a catalog and a cut sheet and a thank you for purchasing a Royer product. And then the final step is the label that puts the model number and the serial number of the microphone. And there you have it. That mic's ready to go on the shelf and be sold.